Today we will solve two problems. Here the first one. The question is given a random sample of size n from under h0 x follows uniform 0, 1 under h1 f of x equal to 2x 0 less than x less than 1. Construct most powerful test for testing h0 versus h1. So this is the question, right? In the last question, we have taken sample size of 1, right? But here we are going to take sample size n. Under h0 we know that under Neyman-Pearson lemma we know that we reject h0 for the large ratio, right? For that here we want to take the likelihood, right? So under h0 likelihood x, because here no parameters, right? Under h0 uniform 0, 1, right? L of x under h0 is equal to, what's that, product I 1 to n f of x. Here uniform 0, 1, then the density is 1, right? Product I 1 to n 1, right? 0 less than x less than 1. Then under h1 here f of x equal to 2x. There is no parameters, right? Then we can write L x1 equal to product I 1 to n. The density is 2x, right? 2xi. 0 less than x less than 1, right? xi right here. Then what's this term? Then we can write product 2 xi as 2 power n product I 1 to n xi. Okay, range is 0 less than x less than 1. Then we have to take the here 0 less than xi less than 1. Okay, then here we have to take the ratio, right? That is likelihood under h1, likelihood under h0. Then what is the answer then? 2 power n product I 1 to n xi 0 less than xi less than 1, 0 otherwise, right? This is the likelihood ratio. From Neyman-Pearson lemma we reject h0 for the large ratio, right? We reject h0 for likelihood under h1 divided by likelihood under h0 is greater than some value k, right? From Neyman-Pearson lemma we reject h0 if L1 of x divided by L0 of x is greater than k, right? Then here which implies what is the ratio? 2 power n product I 1 to n xi is greater than k1, right? It implies here the function of x random variable is the product I 1 to n xi, right? Then we can write product I 1 to n xi which is greater than k2. What is k2 there? k2 equal to k1 divided by 2 power n, right? Here we will make some transformation because here it's product, right? We'll make it as a, you'll take log, right? Okay, then take a log on both sides. Log on both sides, then there is log product I 1 to n xi which is greater than log k2. Okay, what is log? We can write that is a summation I 1 to n log xi, right? Log product xi you can write as a summation log xi is greater than k3, right? That is here k3 is log k2. In test function, we want a function of random variable, right? It should be greater than 0. Okay, it should be a positive. So here, but here in this case, x is takes the value, the range of x is xi is 0 less than xi less than 1, right? Then what is log xi? Then summation log xi. Then summation log xi takes the value between minus infinite to 0, right? That is a negative number, right? So here we need to transform into positive. Okay, then what is summation minus log xi? If summation log xi is minus infinite to 0, then summation I1 to n minus log xi is lies between 0 to infinite. Okay, 0 to infinite is positive. So here we will multiply by minus 1. Okay, that is summation I1 to n minus log xi, which is less than minus, which is less than k4. K4 means k4 equal to minus k3, right? Then the rejection region is summation I1 to n minus log xi is greater than less than k, right? Then what's the test function? Test function for testing h0 versus h1 is phi of summation I1 to n minus log xi equal to 1 if summation I1 to n minus log xi is less than k, 0 otherwise. Okay, so here we need to determine the value of k by using the size of the test, right? Size of the test, that is the expectation of phi of summation I1 to n minus log xi, right, equal to alpha under h0. This size of the test, right, which implies the probability of summation I1 to n minus log xi is less than k under h0, which is equal to alpha, right? Here x follows its distribution under h0. X follows under h0. X follows uniform 0, 1, right? That is the density is x equal to 1 if 0 less than x less than 1, 0 otherwise, right? This is the density of x, right? Then what is the density of minus log xi? If x follows uniform 0, 1, then the density is f of x equal to 1 if 0 less than x less than 1, 0 otherwise, right? Then what is the minus log xi? So here we need to know what is the density of log xi. Okay, for that we will generate we will transform, we will find, okay, what is the density of minus log xi. So for that, let me take minus log x y. Okay, let yi equal to minus log xi. Okay, then what is xi? Then xi equal to per minus yi, right? Y equal to minus log xi. Then what is xi? x equal to e power minus yi, right? Then how to write the density of y here? That is density of yi equal to f of xi into Jacobian, right? Here we need to find the Jacobian value, right? We know what is f of xi, then here we need to know the Jacobian, right? What is Jacobian value then? That is the modulus of dxi divided by dy, right? It's equal to, we have to differentiate that, right? Xi with respect to yi. That is a modulus of minus e power minus yi, right? It's equal to e power minus yi is a Jacobian value, right? Here we will substitute the value f of x equal to, f of y equal to f of xi into Jacobian. Then f of xi is 1 into Jacobian is e power minus yi, right? It's equal to e power minus yi. Here density of minus f of y, that is density of minus log xi is e power minus of xi, right? E power minus, that is e power minus y. Which distribution this f of yi equal to e power minus y, then which distribution here? Y follows, so y is greater than 0, right? Then y follows its distribution, standard exponential distribution, right? Standard exponential distribution, that is here, which implies y follows standard exponential distribution, right? Which implies, then what is summation I1 to n minus, here y means minus log xi, right? Which implies minus log xi follows standard exponential. Then summation minus log xi follows which distribution? Is gamma, right? Gamma distribution. Then which implies 2 into summation I 1 to n minus log xi, which is divided by, then divided by it's the expectation of minus log xi, right? This expectation of minus log xi, which follows chi square 2n degrees of freedom. Here expectation of minus log xi equal to, here minus log xi follows standard exponential, right? Then the mean is 1. Okay, using this we have to obtain the k value, right? Then size of the test, that is probability of summation I1 to n minus log xi less than k equal to alpha, which implies the probability of, here we will make transformation, right? That is 2 into summation minus log xi divided by 1, right? Which is less than 2 into k equal to alpha, which implies here which distribution is a chi square, right? Chi square 2n degrees of freedom, which is less than 2k, right? It's equal to alpha. Here the sign is less than, right? So here we need to make, say, greater than, right? That is, which implies probability of chi square 2n, which is greater than equal to 2k equal to 1 minus alpha, right? Then what is the value of k then? It is k equal to chi square 2n 1 minus alpha, which is divided by 2, right? This is the value of k. Okay, then next we need to find the power of the test, right? Power of the test, that is expectation of phi of summation I 1 to n minus log xi equal to beta, right, under h1, which implies beta equal to probability of minus summation I 1 to n log xi, which is less than k, right? Here under h1, right, under h1 xi follows which distribution? Under h1 f of xi is density is 2xi, right? 0 less than xi less than 1, right? Under h1 xi follows 2, the density is f of xi equal to 2xi, right? Then we have to find out the density of minus log xi under h1, right? Here also we will take y equal to minus log xi. Okay, then what is xi? Then xi equal to power minus yi. Then we need to find the Jacobian, right? That is modulus of xi dxi divided by modulus of dy, right? That is e power minus y, right? Jacobian value is e power minus yi, right? Then the density of y equal to f of xi into Jacobian is equal to, what's the density of xi and the h1? That is 2xi, right? Then Jacobian is e power minus yi, right? It's equal to, here x into here xi is e power minus y, right? Then we substitute what is the value of xi, right? That is e power minus yi, this value, okay, xi into e power minus yi, right? Which implies it's equal to 2 into e power minus yi into e power minus y, right? 2 times, then we can write 2 into e power minus 2 yi. Okay, it's a distribution that where yi is greater than 0. Okay, which distribution is this? It implies yi follows exponential with parameter 2, right? Then summation I 1 to n yi follows which distribution? Gamma, right? Then which implies 2 into summation I 1 to n yi divided by expectation of yi, which follows chi square 2a, right? It implies 2 into summation I 1 to n yi divided by, here yi follows exponential with parameter 2, right? Then what is the expectation of yi? That is 1 by 2, right? Here if x follows exponential with parameter theta, then expectation of x equal to 1 by theta, right? If x follows exponential with parameter 1 by theta, then expectation of x equal to theta, right? Here y follows exponential with parameter 2, right? Then expectation of y is 1 by 2, which follows chi square 2a, right? Then you can write it as 4 into summation summation ya, which follows chi square 2n, right? Then we will obtain the power of the test, right? That is beta equal to probability of summation I 1 to n minus log xi, which is less than k, which equal to probability of 2 into summation I 1 to n minus log xi divided by 1 by 2, which is less than 2 into k divided by 1 by 2, right? is equal to probability of chi-square 2n, which is less than 4 into k, right? Which implies the probability of chi-square 2n, which is less than 4 into, what is the value of k then? It is k is equal to chi-square 2n, 1 minus alpha divided by 2, right? Which implies the probability of chi-square 2n, which is less than 2 chi-square 2n, 1 minus alpha, right? Which implies beta equal to probability of chi-square 2n is greater or equal to, you can write beta equal to 1 minus probability of chi-square 2n greater or equal to 2 chi-square 2n 1 minus alpha degrees of freedom. This is the answer. Okay, this is the power of the test. Then we will go for another question, please. And the question is, given a random sample of size n from distribution with the density f of x theta equal to theta plus 1 power theta plus 1 into x to the power theta 0 less than x less than 1, theta is greater than minus 1. Okay, then for testing h naught theta equal to theta naught versus h1 theta equal to theta 1, where theta 1 is greater than theta naught. Construct most powerful test for testing h naught versus h1. Given a random sample of size n from distribution with the density, that is f of x theta equal to theta plus 1 into x to the power theta, where 0 less than x less than 1, theta is greater than minus 1. For testing h naught theta equal to theta naught versus h1 theta equal to theta 1. Here the test is h naught theta equal to theta 1 versus h1 theta equal to theta 1. Okay, where theta 1 is greater than theta naught, then construct most powerful test for testing h naught versus h1. So here also we have to take the likelihood ratio, right? Then you have to obtain what is the test of the most powerful test, right? Here density is given that f of x theta equal to theta plus 1 into x to the power theta, right? We can write this as theta plus 1 into e power theta log x, right? Then the ratio likelihood is theta L theta x1 x2 so on xn equal to product of this term, right? That is theta plus 1 power n e power theta into summation I 1 to n log xi, right? Then what is under h naught? Under h naught likelihood theta naught x1 x2 so on xn equal to theta naught plus 1 power n e power theta naught summation I 1 to n log xi, right? Then under h1 likelihood theta 1 x1 so on xn equal to theta 1 plus 1 power n e power theta 1 summation I 1 to n log xi, right? Then we have to take the ratio. That is like a ratio under h1 and ratio under h0, right? Is equal to what is the ratio then? Theta 1 plus 1 power n divided by theta 0 plus 1 power n. Then we can write these terms together, right? Okay, e power summation I 1 to n log xi, that is theta 1 minus theta 0, right, which is greater than k1, which implies theta 1 plus theta 1 divided by 1 plus theta 0 power n e power summation I 1 to n log xi into theta 1 minus theta 0 power k1, right? Here the function of random variable is the summation log xi, right? For that, e power summation I 1 to n log xi theta 1 minus theta 0, which is greater than k2. Here k2 is equal to k1 divided by this term, right? Then which implies here we will take the log. Then we can write this term as a summation I 1 to n log on both sides. Take log on both sides, then we can get summation I 1 to n log xi theta 1 minus theta 0 is greater than k3. Okay, which implies here theta 1 is greater than theta 0, right? This is a positive term. Then we will divide by that term. Then 1 by summation 1 to n log xi, which is greater than k, right? Because here theta 1 is greater than theta 0, then it is a positive term, then there is no sign changes, right? And here the rejection region is what is the rejection region? Summation I 1 to n log xi, which is greater than k4, right? But here also x lies between the range of x is 0 less than xi less than 1, right? Then log xi is lies between minus infinite to 0. Then here we also take log xi here, which is 0 to infinite. We want to make this a positive function. Okay, for that, which implies summation I 1 to n minus a log xi, which is less than minus k4, which implies summation I 1 to n minus a log xi is less than k. This is the rejection region. Okay, then the test function for testing h0 versus h1 is phi of summation I 1 to n minus log xi equal to 1 if summation I 1 to n minus log xi is less than k, 0 otherwise, right? Then here also we have to find the k value, right? For that we can use the size of the test, that is the probability of summation I 1 to n minus log xi is less than k, which is equal to alpha under h0, right? Here we will know xi follows the distribution with the density f of x under h0, f of xi theta equal to theta plus 1 e power log e power theta into log x, right? 0 less than x less than 1, theta is greater than minus 1. This is the density of x, right? Then here we need to know what's the density of minus log xy, right? For that we will take y equal to minus log x. Then what is x then? E power minus y, right? Then we have to write the density of y, that is f of y equal to f of x into Jacobian. Then what is Jacobian here? That is modulus of x dx divided by dy, right? It is e power minus y, right? Here then f of x equal to theta plus 1 e power theta into log x, right? Then Jacobian is e power minus y, which is equal to theta plus 1 e power theta. Here log, we are taken that y equal to minus log x, right? Then what is log x? It is minus y equal to log x, right? It is here into minus y, okay, e power minus y. Then we can write this term as theta plus 1 e power minus theta plus 1 into y, right? Where y is greater than 0, that is theta plus 1 is greater than 0, right? Then which distribution is the implies y follows exponential theta plus 1 distribution. Then it implies 2 summation yi I1 to n divided by expectation of yi follows chi-square 2n degrees of freedom, right? That is which implies 2 into summation I1 to n minus log xi into divided by 1 by theta plus 1, right? Which follows chi-square 2n degrees of freedom. Using these we have to find out what is that? You have to find out size of the test and power of the test. Okay, that's your homework.